ChatGPT, Google Search, face recognition, Netflix recommendations. What do all of these have in common? They all run on vectors. And by the end of this video, you'll understand exactly what vectors are, why they're the backbone of AI, and how you can use them yourself. If you're interested in AI and want to actually understand how it works under the hood, hit that subscribe button. Let's dive in. So what exactly is a vector? It's actually simpler than you might think. A vector is just a list of numbers arranged in a specific order. That's it. Nothing scary. Let me give you a real-life example. Imagine you're describing a person. You might say they're 25 years old, 5.9 feet tall, earn $50,000 a year, and have 5 years of experience. Now, if we take just those numbers and put them in a list 25, 5.9, 50,000, 5, that's a vector. Each position represents a different feature, and each number is the value for that feature. You can also think of a vector as an arrow in space. This 2D vector 3, 4 points to a specific location. The first number tells us how far to go right, the second tells us how far to go up. Now here's where it gets interesting for AI. Here's the thing about AI, it's actually pretty dumb in one way. It can't understand words. It can't see images. It can't hear sounds. Not directly, anyway. AI only understands one thing, numbers. So everything, and I mean everything, needs to be converted into numbers before AI can process it. And vectors are the perfect way to do that. Let's take a simple example. How would you describe an apple to an AI? Well, you could say it's red, let's give that a 0.9 out of 1. It's round, that's 0.8. And it's sweet, 0.7. So an apple becomes the vector 0.9, 0.8, 0.7. Now do the same for a banana, maybe 0.2, 0.3, 0.8. And just like that, the AI can now compare apples and bananas mathematically. It can see that apples and cherries are more similar than apples and bananas, just by looking at how close their vectors are. There are 3 main types of vectors you'll see in AI. Let's go through each one. First up, word embeddings. This is how AI understands language. Every word gets converted into a vector with hundreds of numbers. King becomes a vector, queen becomes a vector, man and woman each become their own vectors. And here's the mind-blowing part. If you take the vector for king, subtract the vector for man, and add the vector for woman, you get a vector that's incredibly close to queen. King minus man plus woman equals queen. The math actually captures the meaning of words. This is the foundation of how ChatGPT and other language models work. Type 2, image vectors. This is how your phone recognizes your face. An image gets broken down into pixels, processed through neural networks, and comes out as a long vector of numbers. Your face has a unique vector. When you try to unlock your phone, it compares your current face vector with the stored one. And third, feature vectors. These are used for any kind of structured data. Health data, financial data, user preferences, all of it gets organized into vectors. Your age, height, weight, blood pressure, boom, that's a feature vector. Now let's see how this actually works in the real world. How does Netflix know what movies to recommend? Imagine we have 3 movies, and we rate each one on 3 scales: action, romance, and comedy. Movie A is mostly action, high action score, low romance, low comedy. That becomes the vector 0.9, 0.1, 0.2. Movie B is a romance 0.2, 0.9, 0.3. Movie C is also an action movie 0.8, 0.2, 0.3. Now if you liked movie A, which movie should Netflix recommend? Let's plot these vectors. Look at this. Movie A and movie C are close together in this space. Movie B is way off in romance land. The answer is obvious when you visualize it. Recommend movie C. This is exactly how recommendation systems work. Similar content has similar vectors. So how do we actually measure similarity between vectors? There are a few key operations. First, distance. This is like measuring how far apart 2 points are on a map. You take the difference between each pair of numbers, square them, add them up, and take the square root. Smaller distance means more similar. It's that simple. But the most popular one in AI is cosine similarity. Instead of measuring distance, it measures the angle between two vectors. If two vectors point in the exact same direction, their cosine similarity is 1, they're identical. If they're perpendicular, it's 0, unrelated. If they point in opposite directions, it's -1. This is what Google uses to match your search query with web pages, and what ChatGPT uses to understand context. And the code to do this is surprisingly simple. Just a few lines of Python with NumPy, and you're calculating cosine similarity like a pro. I'll put the code in the description. Let's quickly run through where you encounter vectors every day without even knowing it. ChatGPT converts your messages into vectors to understand what you're asking. Google turns your search query and every web page into vectors, then finds the best matches. Face ID on your iPhone? Vectors. Spotify recommending your next favorite song? Vectors. Tesla's self-driving system processing camera and sensor data? You guessed it, vectors. Alright, let's wrap this up with 4 key points you should remember. 1. Vectors are just lists of numbers that represent data. 2. AI needs vectors because it can only work with numbers. 3. Similar things have similar vectors, they're close together in vector space. 4. Vectors power everything in modern AI, from search engines to self-driving cars. And that's Vectors in AI explained. If this video helped you understand this fundamental concept, smash the like button and subscribe for more AI tutorials. Drop a comment below, what AI topic should I cover next? I'll see you in the next one.